I didn't need to get to the gas station. It just broke.
It's a motorized bike.
Literally just like.
All right. We'll wrap up 4-2. We'll do 4-3. So 4-2 is lines of symmetry. Do you remember my analogy yesterday of folding a piece of paper with a chalk drawing on it? And when you fold it, it imprints the chalk on the other side, and you see what the reflection looks like. So what does that mean? That means your fold line is your line of symmetry. It's a line of reflection, but it's also going to be a line of symmetry in a picture. This beautiful butterfly has a line of symmetry. Okay. All right, so let's talk about it. Determine whether each polygon has line symmetry. If so, draw the lines and describe any reflections that map the polygon onto itself. So looking at this trapezoid, who could describe to me where the line of symmetry is? Andrew, help me out.
Right down the middle.
Down the middle, I like it. Any other lines of symmetry? Or is it just that one? Ben, what do you think?
Go from the top right or top left to the opposite corner.
This could be tricky. Let's see. Someone was very vicious and just said no as soon as you finished that, Ben. I'd watch out, Ben. I'd watch my back. Now, this is not a perfectly scientific approach for me to do it this way. If I had like a protractor or something, I could draw it better. But do you guys agree that's pretty close to being perpendicular? Why would I draw on a perpendicular segment? Well, yesterday we learned that if you're going to reflect it over a line, then it's going to be the same distance on that side of it, correct? So if we took that segment and extended over here, that point would end up being over here. So Ben, even though it looks like it, it's not going to quite be symmetrical over that one, okay? So this one, I think, just has one line of symmetry. What about the next one? This hexagon. Think about it. Lock in your answer. We're going to take a quick poll. Eldon.
I got 12.
12.
Oh,
Cole's like, I'm not sure anymore.
Well, I gotta think about it.
Well, you had your hand raised.
I didn't know you were asking for the amount of like lines of symmetry. I thought you were just asking for like
For
certain
one.
ones. Yeah.
Daniela.
I went there 6.
6.
I got 12.
12. Wait. 12? Let's see. Now, do I need to make a new rule? Once a line of symmetry has been drawn, if you're counting, like you're going around drawing them, and you start overlapping, it's not a new line of symmetry. Do you know what I mean by that? Let's draw. Everybody see 1. Do you agree? This point, that point would be on the same side or same distance from that line of symmetry. 2, 3. Everybody good with 3 so far? So I guess the directions did say draw the lines of symmetry and describe any reflection. So maybe I would describe, if I want to get really nerdy, I would say if all these purple lines of symmetry go through the midpoints of the sides of the polygon. Correct? Line through the midpoints of the sides. The next sets are going to be through the vertices. Is this an accurate line of symmetry? Well, the points on it aren't going to get reflected, or they're going to get reflected, but they're going to stay put. How about these ones? Are these equidistant from the line of symmetry? And would they fall on top? Would it map onto itself if you reflect it? Is the green one a line of symmetry? Yes? How about this one? Yes? How about this one? How many are we up to? 6. 12, were you counting them?
I counted all the
Yeah,
lines
no.
across.
So yeah, and that's why we have to kind of make a rule. Like once you've drawn it, going the opposite way is the same line as what you've already drawn. So that's already been taken. I can see why you said that. So this is why it's important to discuss it and say, okay, once you've drawn it, it counts, you're done, don't count it again. All right, next. Parallelogram. Lines of symmetry. I see a heart.
It's a 0.
Oh, that's not a 0. I thought you were going like, oh, I love this problem.
Yeah.
I hear 0 with a heart.
1.
1. Describe.
That way?
Like this?
No.
Like this?
No. From the top left corner to the bottom.
Like that?
Yeah. Oh wait, no.
Ah! When I'm grading these quizzes, I'm going to see a bunch of folds. Like, I'd be okay with that. I don't care. I'm not that picky. Like, you're going to be like, oh, I'm going to fold the paper and see. Like, what if you think that is a line of symmetry? And Ella, I think this would be one where I would test it. Like, I would kind of eyeball test it and draw like 1 point and say, okay, there's that. And then it kind of looks like it could, but it's not quite, right? So we test it and we're like, oh, not quite. Hey?
I don't know how to explain it, like, it's kind of diagonal, but like, it's going like the shorter sides.
These ones?
Yeah.
But going like this?
Going through the middle.
Like this?
Yeah.
I think this point would actually end up over here. And this point would end up over here. So I don't quite think that's going to be a line of symmetry either. Anybody else? Mackenzie, is your mind blown?
No, I can't think.
Oh. That would also do that reaction. Anybody else want to give it a shot? Or are we okay with Chris's heart? /0. There are 0 lines of symmetry. Broken heart. All right. No, I don't think you guys were that heartbroken over that one. Questions about lines of symmetry? That was the finish of 4-2. On to the 4-3 notes. Rotations. Rotations. All right. Yes, Kate.
What's the answer to this question?
Oh, did we not fill it in?
It's 9 symmetry.
All right.
No way.
Apparently, this analogy did not work very well second period, but I'm going to do it again because deal with it. Now, I know someone has to know what I'm talking about. How many of you ever seen the novelty watches, like old school, like tick, 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 that have like a figure on like the second hand, like a Mickey Mouse watch? Like, okay, thank you. Okay, it was second period. I had no idea what you were talking about. Sorry if anyone from second period's watching the video today. I'm recording this class as I forgot to earlier. All right, so don't say anything stupid. Do you know what I'm talking about though? The Mickey Mouse face, or no, it's a hand. It isn't it? Okay. So yeah, with the glove. Thank you.
Good job.
Thank you. Now you know what I'm talking about. What happens to the hand? It goes tick, 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 tick. The center of the watch is the center of its rotation, right? It's center of the rotation. And so when it's down at 6 o'clock, the hand is upside down. When it's over here at 9 o'clock, something's gonna crack. It's like this, and then when it's up here at 12, it's like that. All right. That is a rotation. That is a rotation. It changes its orientation. It's not being reflected. It's not being translated. It's rotating. Now, every rotation we do in this class will be a, look at the top right of your guided notes, study tip. Counterclockwise rotation. So Mickey's got to go backwards, okay? Because these are all counterclockwise rotation. Make sure you notice that. All of ours this year will be counterclockwise. So if you don't know what that means, look at the way the clock's going right now. The second hand. And it's not that way. It's the other way. All right? Counterclockwise. All right. This first drawing is of a 40-degree rotation, where P is the center. 40 degrees would be the angle of rotation. However, we're not going to deal with 40 degrees. We're not going to get out protractors for this. We're only going to be doing these on a graph. The three main types of rotations we're going to do are 90 degrees, 180, and 270. Ooh, a delivery. Thank you, sir. Should we open it?
Yeah.
I didn't order it. Hold on, I can probably tell from the. It's not that exciting. I'm getting new calc textbooks next year. It's probably nerdy calculus book. What?
I don't think the box would do that much.
I can't hear you, Peyton.
I don't think the book would do that much in the box.
It's hefty. They didn't pack it very well. I guarantee there's none of the packing air in here.
Well, that's like Peyton wrong. I said, why did it move so much?
But they didn't pack it very well. I have a lot of.
You just have boxes sitting there.
I need to look through them and pick a book, but I don't want to.
We found the watch face. Did you get it? Yeah. Yeah.
Oh, it's a finger.
Yeah. It's like
Yeah,
it's like
I guess a hand wouldn't be that accurate. Like, oh, which one are you pointing at?
it's the
All right. Our rotation rules. You need to know these. You need to love, maybe not love them, but you need to know them. Okay? Thank you. Here are the rules. If you prefer to use X's and Y's, every XY point transforms into negative Y X if you're rotating 90 degrees. This is the 90-degree counterclockwise rotation rule. Yesterday, we tried to figure them out because reflections were pretty easy to figure out, weren't they? You guys had them in about 10 to 20 seconds, didn't you? Why? Because my philosophy is if you can figure it out and it's something you don't have to memorize, then don't. Because there's enough to memorize in life, okay? So if it's something you can figure out, I probably wouldn't waste time trying to memorize it. This, I think it's harder to figure out. So we're going to memorize these. If you want to use flashcards, if you just want to, a good exercise while you're doing it every time would be to write out this rule before you start the problem. Or the next rule for a 180. The 180 rule is XY turns into negative X, negative Y. Now, when I say negative, I really should be saying opposite. Because what if the number's already negative? Well, it's the opposite of that. So if it was negative, that was positive. And if it's opposite of X and opposite of Y, then whatever they were here, their opposite signs are there. And that's your new point. After you've rotated 180. Now that one makes sense, right? Look up here. If you're up here at AB and you want to go tick, 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 90, tick, 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 180. Oh, look at those points. It's the opposite of A and the opposite of B. That one seems to make more sense to people. Would you agree? Maybe not. All right. Last one is 270. 270 is all the way back to here. And the rule is y, comma, negative x. Why isn't there a rule for 360? Cool.
Because there is no change.
You'd be back to where you started, right?
Yeah.
No change if you rotate 360. All right, let's do some examples. We're going to graph this. R is 3, 1. 2, 3, 1. S is 5, 1. And T is 5, negative 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. And U is 2, negative 1. All right, this is a quadrilateral. We're going to connect the vertices. All right, we're going to rotate it 270 degrees about the origin. What does the origin mean? The origin is the point 0, 0. That is the center of our clock. Okay, in this clock design we're dealing with today, for this problem, nobody would buy it, okay? Because on the end of this second hand is a ugly quadrilateral, all right? Maybe people would buy it, I don't know. Math nerds. Now watch, here's what's gonna happen. Pretend that you take, for just a mental visualization, pretend you take a little stick or something and glue it onto this quadrilateral. And it goes tick, 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 90, tick, 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 180, 270. Can you envision it rotating around? Counterclockwise. Counterclockwise. All right, so here we go. The rule is, and again, the more you write this, the easier it will be to memorize. The rule is xy turns into y, comma, negative x for a 270 degree counterclockwise rotation. Counterclockwise can be abbreviated CCW. Counterclockwise. Well, we have 4 points. We have R, which was 3, 1. We have S, which is 5, 1. We have T, which is 5, negative 3. And we have U, 2, negative 1. We do have you. And you are special. But not you. I like whispering too. All right, what is R prime? Let's call on some people to figure this out. Our xy turns into y, comma, negative x. Grace, help me out. 3, 1. 3, 1 is going to turn into... Nailed it. 1, negative 3. Does everybody see how we do that? Everybody can use the rule? 1, negative 3. And we're going to graph it. 1, negative 1, 2, 3. And name it, Cole. Make sure you name it on your paper. Cole, did you write it down?
Mm-hmm.
Did you name it?
Yeah. Go ahead.
Good job. R prime is 1, negative 3. Next, we have S prime. S prime. Whoops. Daniela, help me out. What's S prime going to be?
1, negative 5.
1, negative 5. I like it. 1, negative 1, 2, 3, 4, 5. S prime. T prime. That'd be a good rapper name. T prime. Is there like a T-Pain?
Yeah.
Is there? Okay. Is that like a current rapper or a really old rapper? Older.
Judy.
See, I looked it up yesterday. It actually said in the definition, someone who's trying too hard to be trendy. Not necessarily bringing back something old. Do you agree, or is it just not how you heard it in context?
I agree.
I'll
Both
say
of them?
both of them mix.
Both of them? All right. T prime. 5, -3. Robin, what do you think for 5, -3 using the rule?
Would it be -3, -5?
It would be. -1, 2, 3. -1, 2, 3. T prime. And U prime. Jace, what do you think?
-1, -2.
Good. -1, -1, 2. Give it the eyeball test. Does it look like it's been rotated 270 degrees? First of all, first eyeball test is, has it changed shape at all? Did it change shape? No, it looks like we kept it the same shape, right? Did it change size at all? No, so we've been calling these rigid motions. They don't change shape or size. So is the location correct then? Can you see it? If you were to imagine kind of drawing a little segment to R, a segment to R from the origin, and then a segment to R prime, does that look like it's gone 270 degrees around? What's 270? Isn't it 90 short of 360? Does it look like there's 90 left to go? Yeah, that looks pretty good to me. Do you see how you can kind of give it the test there? Awesome, good talk. All right, so graph it, label the points, good shape. So we did mention it. A rotation is a rigid motion. It doesn't change shape or size. Keeps the segments and the angle measures the same. Next, we're going to do a composition. No music involved. No English involved. We're going to do 2 transformations. We're going to reflect first, then rotate. So after the reflection, I'm going to call the new points R prime and S prime. Then after the rotation, we'll have R double prime and S double prime. So we're going to have 2 transformations. But first, let's graph the original. 1, -1, 2, 3. And 2, -1, 2, 3, 4, 5, 6. So first, reflection. Reflection over the y-axis. Here's the y-axis. What's R prime going to be? Well, R was 1, -3. 1, -3. Let's go with Silas. What do you think? If R was at 1, sorry, I interrupted you. R was at 1, -3. Now it's over the y-axis is going to be at good, -1, -3. And Silas, is that one you memorize or you just kind of look at it and like, oh yeah? Yeah, me too. So R prime is going to be right here. Same distance away from the y-axis as R was, just on the other side. S prime. Caleb, what do you think for S prime?
-2, -6.
Nice. -2, -6. -2, -1, 2, 3, 4, 5, 6. S prime. There's R prime. There's S prime. We are done with the first transformation. Step 2. Rotation. It's getting glitchy on me. 90 degrees. 90 degrees. For a 90-degree rotation, my recommendation was to write out the rule to practice. 90-degree rotation. What's the rule? XY turns into negative y x. XY turns into negative y x. Now, am I taking r and rotating it, or am I taking r prime and rotating it? What do you guys vote? Do I take r and rotate it 90 degrees, or r prime and rotate it 90 degrees? Grace, or not Grace, I'm sorry, Novely.
R prime.
R prime. Thank you. So r prime, which was, what was it, -1, -3, becomes r double prime. And Novely, do you wanna take that one or pass it off to someone?
I think I got it. Is it 3 -1?
It is 3 -1. The rule says, take xy, take the y value and make it opposite. So she took -3 and made it opposite. And then she put it in the first position, which is the x location of the point. 3 -1. So 3, 1, 2, 3, -1. And we call it r double prime. 3 -1. S double prime. Nope. Sorry. Got excited. S prime, which was -2, -6, turns into S double prime. Ava, you got this one?
Yeah, 6 -2.
Good. 1, 2, 3, 4, 5, 6, -1, 2. S double prime is 6 -2. And again, if you want to give it the eyeball test, this is the origin right here. And this really boring watch would have this red segment go tick, 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 end up over here. And it does look like it's been rotated 90 degrees. Do you see how to kind of test it visually? By looking at it? I see one person nodding. It seems like I've done a good job this period. One person understands. It's a good day. All right, awesome. Last 2 slides. Identifying rotational symmetry. Okay. So now we have to look at a picture and kind of like the lines of symmetry, but don't think of it as the same as the lines of symmetry. Here's what we're doing now. Now we're taking the picture and we're rotating it, and we're figuring out, one, how many rotations, how many times within a full rotation will it get mapped onto itself. And I actually think the best one up here is the octagon to start off with. And within this software that I'm using, it has a really nice feature. I kind of grouped this dot onto the octagon, and watch as I rotate it. I need you guys to watch up here. Here's the test. You have to look at the octagon, and obviously you're not going to have the benefit of having the software when you're doing this. So just kind of have to visualize it. But imagine a dot being on some point on the octagon. It doesn't matter where. And then as you rotate the octagon, you're asking yourself, how many times does that dot get mapped on to the original picture of an octagon? So, like, would you agree there's one? Right, I started with the dot there. 2, 3. And you see there, it just doesn't look right. Not yet. 4, 5, 6, 7, and then the 8th one would bring it back to where it started. So let's read the directions. Determine whether each polygon has rotational symmetry. So if it took a full turn, this is a definition, you just have to know this. If it took a full turn to get back to the original, that doesn't count. Okay, 360 is not rotational symmetry. If it took a full time to get back, that's just the original. Okay. So does the octagon have rotational symmetry? Yeah. So yes for this one. If so, describe any rotations that map the polygon onto itself. Well, how are you supposed to figure out how many degrees it took to rotate for it to map it onto itself? Well, let's figure it out. How many degrees are in a full rotation? 360. How many times did it get mapped onto itself? 8. So 360 divided by 8. Do you need a calculator for this? Do you want to do it without a calculator? Do you want a little mental math practice? Do you want to know how I did it? If you can divide by 2, and then divide by 2 again, you've now divided by 4, and divide by 2 again. So here we go. 360 divided by 8.
45.
Is that Robin? Did you use your calculator? Robin, I said no calculator! So what's 360 divided by 2?
13.
This is not going to work. What's 360 divided by 2? 180. Divided by 2 again. 9. So that's 4 divided by 4. And then divided by 2 again. So we divide by 8 because we divided by 2 3 different times. 45. 45 degrees. Okay. That was confusing? You guys need to work on mental math. Isn't dividing by 2 3 times the same as dividing by 8?
No.
Yes.
Yes, correct.
Did I say, what did I do? 4? Oh, I said 3.
Yeah, it's 4 times.
I did it 4 times, but I said 3. Sorry. All right, watch up here. Here's what you're saying. From here to here, it rotated 45 degrees. Do you agree? That was the first, the old book, we called it the order of rotation. Order. First one, 45. What was the next one? So 45 degrees, counterclockwise. Then 90. Then, it's going to get really dicey here. 135. Then 180. Then
225.
she doesn't need the calculator anymore. Then
270.
270. Then, oops, sorry, 315. All right, I've seen it both ways. Some books will not include the final 360 because it's the last rotation. It's the last 45. Okay. If it's the only one, if 360 was the only one, then it doesn't count as rotational symmetry. Okay. But since it was one of the 8 to finish off the 8th one, okay, it gets counted. So describe any rotation. So any of these rotations would have mapped it onto itself. Does a trapezoid have rotational symmetry? Did it have line symmetry? Yeah, remember the line we drew through it? Does it have rotational symmetry? No. All right, the homework's accurate this time. Don't forget the even part. Don't just do 12 to 20. 12 to 20 even after 508 all. No, it is divided by 3. Divided by 2 3 times. No, watch.
You know, because 2 times 2 is 4 times 2 is 8.
I take the circle. I divide it by 2. Okay? I divide it by 2 again. How many pieces are down?
4.
And if I divide all those by 2?
So it's basically saying 2 times 2 4.
It's 1/2 times 1/2 times 1/2. It's 1/8. Not adding. You guys have me second guessing myself. Let's work on it. We'll work on it. We'll have an after math club. Mental math club.
When I was in the math team, I put mental math in my last thing as a team, and I was like, I can't. You put me in for mental math.
How are you at mental math, Ava?
I still typed in like 5 plus 8 in my calculator.
Have a good day.